with a trig function, sine of 2n. So it's being divided by 1 plus n. Well, the biggest that sine can get is 1. If you're then dividing that by something, it's just going to get smaller and smaller and smaller as n gets bigger and bigger and bigger. So my guess is that the answer is going to be this converges down to 0. If that's my guess, I should be able to prove it by taking the limit as n goes to infinity, and then it would be sine of 2n over 1 plus n. Now, what if we use L'Hopital's rule? We'd have the limit as n goes to infinity. The derivative on the bottom is going to be 1. The derivative of sine is cosine. And then take the derivative of the inside. There we go. And so then, how much is cosine of infinity? Well, cosine keeps going up and down and up and down and up and down and up and down forever. That means it doesn't have a limit. So this limit does not exist. So what happened to my reasoning of this is basically 1 being divided by something, a something that's getting bigger and bigger and bigger? That means 1 divided by it is going to get smaller and smaller and smaller until it's 0. Was that reasoning wrong, or did I do something wrong over here? Well, I could take a look at the graph and see, is that first idea reasonable? So take sine of 2x divided by 1 plus x, and then take a look at the graph. So there's sine trying to bounce up and down, and then it's being divided by 1 plus n, so that's making it shorter and shorter and shorter. And if you follow this out, say to 25, there's sine's bounciness, and it's being sapped away. Its energy is being sapped away. Or this is much like a sound wave. When it first happens, it's loud, and then it gets quieter and quieter and quieter. So it seems that the answer is 0. So, can you tell me, I must have done something wrong here. What is it? That's right, you guessed it. You're not allowed to use L'Hopital's rule, because L'Hopital's rule is only for situations that have either 0 divided by 0, called indeterminate form. This is not. This is going to infinity, so the other way you can use it is if it's something that's infinity over infinity. But as I said, the biggest that sine gets is 1, so this is not infinity, thus you're not even allowed to use L'Hopital's rule. I don't usually do this, make a mistake on purpose to demonstrate something, but this is such a very common mistake that I see students make, I just have to point it out. They see L'Hopital's rule, they say, I love it, I'm going to use it all the time. Well, you can't use it all the time. So what we could do is say sine of 2n is always less than or equal to 1. Then I could say, well, divide both sides of that by 1 plus n. So the sequence we're talking about is always less than or equal to this one. Then if you take the limit as n goes to infinity on both sides, then look what happens on the right hand side. So this is going to be 1 divided by infinity, and that is so small it becomes 0. Therefore, the limit as n goes to infinity for this thing has to be less than or equal to 0. Well, the only thing that's less than or equal to 0, and I could have done the same thing on this side with having sine be negative 1, and then I would have done the same thing over here. There's the whole thing. So then this side, the same thing would happen. You'd get 0. This side, you'd get 0. And that says our problem, the limit as n goes to infinity on this thing, is somewhere between 0 and 0. Therefore, the limit equals 0. That means converges.